Hello, my name is Matt Stricker and welcome to Math 220. This is the first video we're going to be going over this semester, and it covers section 1.5 from your textbook and your notes. It covers the topic of substitution, which should be a review topic for you from Math 210 or Calculus 1. It should have been something you should have done at the end of the semester. If not, you will see a bunch of extra resources on the page that you link to this video from, with extra examples for you to check out. It is something you're going to want to get up to date with quickly if you're not comfortable with it right now. And because it's review, I'm not going to spend a whole lot on how to do these problems. I do want to go over a couple reminders for you. The first one is a reminder that this is the opposite of the chain rule. It's an integration rule for undoing the chain rule, which you can see right here. Here's our chain rule. And so it basically takes an ugly looking integral like this guy over here. It takes an ugly looking integral like that and makes it simpler. And we do that by making a substitution. And the important thing to remember is that we're always typically going to let u be that inside function. So if you're looking at an integral and you have a function that's inside of another function, that's typically going to be what we're going to let u be. It's not always the case, but a lot of times that's the case. So if I skip down here, you can see, of course, the theorem here that's in the textbook. I'm going to skip over that, and I want to jump into these examples. And you can see example 1 here. There are two integrals, and each of them has a composition of two functions. So the first one is the cosine of 4x. The function 4x is inside of cosine. And then the second one, the function 3x plus 5, is inside the square root function. So if I do that, if I let u, as I suggested previously, if I let u be the inside function, in the first one, I would let u equal 4x. And then we calculate the differential, which would give us du equals the derivative of 4x is 4. Then we add a dx on the end. And depending on how your teacher taught this, they may have you solve for dx. That's how I do it. So if you solve for dx, you get dx equals du over 4. And then you go and you make the substitution. So if I come back here and I rewrite this integral after substituting what we've done, first of all, it's not going to be the cosine of 4x anymore because 4x is now equal to u, so that's going to change into the cosine of u, and then dx is now equal to du over 4. So we have du over 4. And anytime you have constants like this 4, it's always better to move that out to the front. So if I move that 1/4 out to the front, then we can rewrite this as the cosine of u du, and you'll notice we now have an integral that is much, much simpler. And so we know that we can now take the antiderivative. The antiderivative of cosine is sine. And the sine u, we have, don't forget about our constant of integration. And then, of course, you can back substitute. So the u is equal to 4x. And that's our answer. So that's kind of a basic introductory example to reviewing how to do a u substitution. Your teacher may have also talked about being able to perform a mental u sub, and that's what you get anytime you have one of these simple integrals where it's just the inside function is a constant times x. And you're always going to end up with whatever that constant is times x, you're going to end up with 1 over that constant out front. So for example, if I had the same integral, but instead of cosine of 4x, it was the cosine of 2x dx, then this would be equal to 1/2 times the sine of 2x plus c. And you could do that with other integrals as well. Let's say we had like the integral of e to the 3x dx. We could do a mental u sub on this because we'd let u be 3x, which means we're going to end up with a factor of 1/3. So you get 1/3 e to the 3x plus c. So hopefully that's not something that's too unfamiliar to you. Of course, you can verify these two answers that I just showed you by going through the full process, but it's definitely easier in calculus if you can just kind of recognize those answers. Let's do one more problem on this video, and then we'll go ahead and move on to the next video where we'll talk about doing definite integrals for u substitution. So if I look at the next one, again, we want to let u be the inside function, so we're going to let u equal 3x plus 5. Then du is equal to the derivative of 3x plus 5, which is 3 times dx, which means dx is equal to du over 3. And then we'll go ahead and make our substitutions, and you end up with the integral of the square root of u, and dx is du over 3. And then it's always nice, if you remember, to make our square roots, anytime we have square roots, to treat it as a power, so that's u to the 1/2 power. And I'm going to go ahead and move that 1/3 again to the front like we did in the last example. And then we can just use the power rule. So leave the constant there. Remember, for the power rule, you add 1 to the power. So you add 1 to 1/2. You add 1 to that, you get 3/2. So this will be u to the 3/2, and then you're going to divide by that same power, divide by 3/2 plus c. And then remember, of course, also instead of dividing by that power, you can go ahead and multiply by its reciprocal. So that's 1/3. Instead of dividing by 2/3 or 3/2, that's multiplying by 2/3. We have u to the 3/2 plus c. We can simplify this. 1/3 times 2/3 is 2/9. And then we can back substitute that u is equal to the 3x plus 5 raised to the 3/2 power plus c. There's your final answer. There are several more examples here on this first one. There's C, D, and E. I will post the solutions to those so you can see those answers worked out if you would like. And I'm going to go ahead and end this video. Next video we'll talk about doing u substitution with definite integrals. Thank you.